Hello everyone, I am Siddharthan. Currently, we are in the eighth module of our hands-on machine learning course, and in this eighth module, we are discussing about the topics such as cross-validation, hyperparameter tuning, model selection, etc. And in my previous video, I explained you what are all the different factors that we have to consider while choosing the right model for a machine learning problem, and we have also seen for which kind of dataset we have to use which kind of model and so on. And in today's video, let's try to understand how we can perform this model selection in machine learning with Python. So this will be the agenda for today's video, and let's get started. So here we will be taking a sample dataset and we will be performing this model selection in order to understand this process. And for this, we are taking this ArtDisis dataset. In my channel, I already made a video called Art Disease Prediction using machine learning. So we are going to use the same dataset that we had. So this dataset basically gives us the data on whether a person is having any art diseases or not. So this is a typical classification problem. And in this case, we are going to take five models and compare their, compare their accuracies and see how we can perform this model selection. So that is what we are going to do in this particular video. So these are the steps that I've already done in that video as well, but I'll quickly explain you what are all the steps that we are doing here. Okay, so the first step is importing the dependencies. Dependencies are nothing but the libraries and the functions that we need. So first of all, I'm importing my NumPy library and pandas library, and from sklearn.model selection we are importing cross-val score. So in sklearn library, we know that in sklearns we have various functions for training our models, several models like logistic regression, protected machine, etc. So there is also a module called as model selection. So in that we have a function called as cross-val score, which is basically gives us the cross-validation score of a particular model. And we have already seen this while we have discussed about the scaffold cross-validation and all of those things. I hope that you have seen those videos. If not, I'll give the link for that video as well in this video description. For this art disease prediction also, I'll give the video in this description. Okay, so I'll give the link for that. And then we are importing this grid search CV. So grid search CV is what we call hyperparameter tuning technique, where we pass like several hyperparameter values, and this grid search CV will try to tell us which hyperparameter is the best that we can consider. Best in the sense, when you use those hyperparameters, you will get the highest accuracy for that machine learning model. So we are importing these four dependencies first of all, and later we are importing the models that we are going to use. So in this case, as I've told you, this is a classification problem because this contains the target variable as either 1 or 0. 1 being a person has art disease and 0 being a person doesn't have any art disease. So this is a classification problem. So we are importing five classification models that we have. The first classification model that we are importing is logistic regression, which we are importing from sklearn.linear model. Then we are importing the protected classifier, then k nearest neighbor classifier, and random forest classifier. So these are all the five models that we are going to take, and we will be comparing their accuracies. Okay, so I think like there are like four models, not five models. There are like four models which you are going to use. And as I've told you, this is the ArcGIS prediction data set. I'll give the link for this data set in the description of this video as well. You can download that file and upload it here. So I have already uploaded this file, so you can upload it here and do all this processing. So once I upload this file, I'm reading the CSV file to a pandas data frame using this read CSV function. So we know that this is a very common and basic function that we use, and I'm storing this data in a data frame called as art data. Okay, so in this I have to give the path of the CSV file. After that, I'm printing the first five rows of the data frame that I've created using the set function. So these are all the first five rows that we have. So if you want a clear detailed explanation on what are all these different columns that we have and the other things, you can watch that art disease prediction project. So here I'm just quickly going through all the steps that we have done, and then we are checking the shape. So how many rows and columns are there in this particular data frame? So as we can see, there are 303 rows and 14 columns. Okay, 303 means 303 data points or 303 different people are there in this data frame, and we are checking whether there are any missing values. Fortunately, there are no missing values in this data set, so we can move on to the next step. Then we are checking the distribution of the target variable. Here, as you can see, I'm mentioning the data frame name and the target column name and value form. So this is the function that tells me how many values are there in each class. So there are like 165 data points in one class and 138 data points in the class 0. So the distribution is almost equal, so we don't have to do anything. So in case the distribution is not even, in that case we have to do upsampling, downsampling, and so on. So here 1 means defective art. That means like a person is suffering from art disease. 0 means a person doesn't have any art disease, and so on. So now we are separating these features and target. Features are nothing but these columns. So we have this age, sex, CP, BPS, and so on. So we have various columns here, and one column is this cholesterol and so on. So based on these factors, we have to tell whether a person will be having, our disease or not, whether the value is 1 or 0. So these columns from age to this last before column is my features, because with using these values, I'm going to predict whether the target value is 1 or 0. Okay, so I'm going to separate all these values separately and target column separately. So that's what I'm doing here. So I'm storing all the features in my X, and I'm storing my target column in this Y. Okay, so I'm separating it, and you can see I'm printing my X. So these are all the columns. Now it doesn't have this target column, and Y as the target column. So these are all the things that we have done so far, and after this we can perform our model selection steps that we have. Okay, so you don't have to separate the data, training data and test data. So we will do that in the later part of the code, but you don't have to do that. So I'm separating my features and target as X and Y, and after that I'm converting it to a NumPy array. So instead of having it in the form of data frame or a series, I'm converting it to a NumPy array, and you can do that by using NP. So NP means NumPy library using as array function X. So I'm converting this X into a NumPy array and Y into a NumPy array. Okay, and now we will do this model selection. So in this model selection, we will perform like two ways, like two things we will do here. One is like comparing the models with the default hyperparameter values, and then we will also compare the model, or we will select the models with different hyperparameters. Okay, so first thing that we will do is I'll just make a text here as comparing the models with default hyperparameter values. Okay, so default hyperparameter values using cross validation. So this is why I've imported this cross val score function, cross validation. Okay, so this will be the first step, and later we will compare the models with different hyperparameters as well. So there are like two parts for this particular video. And first of all, let's try to create a list that contain all these models. So we have imported these models, right? Logistic regression, SVC, k nearest neighbor, and random forest classified. So here I'm going to create a list. So this will be a list of models. You can also try other classification models as well if you want. So models is equal to, so this is the list that I'm creating. The first model is logistic regression. Okay, so logistic regression. So this is my first model, and the second model is support vector classifier, which is SVC, and k nearest neighbors. So k neighbors classifier is my third model, and finally I have my random forest classifier. Random forest classifier. So these are all the four models that I'm taking, and I'm going to like give a few values to it. So in this logistic regression, I'm going to give this max iter. So max iter basically represents the maximum number of iteration, and I'm going to give this maximum iterations is equal to 1000. And support vector classifier doesn't work if you just mention this SVC. You have to mention at least one kernel value. Okay, otherwise it won't work. So I'm going to say kernel is equal to linear. So it is the most default one and the basic kernels that we have. So apart from this, we also have this polynomial kernels and other type of kernels as well. So kernel is equal to linear kernel for support vector classifier, and then we have k nearest neighbor, so we don't have to give any parameters here. And random for us, we will set a random state. So if you don't include this random state, you will get slightly different accuracy score each time you run this. So I'm setting my random state. So if you give some random state, your accuracy value will be the same if you train this random forest classifier multiple times. So that is the reason. And the reason I'm giving this max iter is that we are not standardizing the data in this case. As we can see, we are using the data in this same format. So it will give us an error if we don't standardize the data before using it in logistic regression. So we are increasing this max iter, but the correct way would be will be in order to it will be to standardize the data, but we can't use it using this cross validation directly. So we have to use something called as pipeline. So we have to build this pipelines and pass this standard scalar and research CV and so on. So it is a bit complex. We will discuss about that later, but for now understand that we are using this maximum iter so that it doesn't give us any warning. So that's the reason, but we will discuss about this pipelines later on. So here I created a list called as model, and I have like four models here. First is the logistic regression model, and the support vector classifier model, k nearest neighbor, and random forest classifier. So these are all the four models that I'm considering. And now I'm going to create a function that will compare the accuracy score of these models. So if you remember, we have already done this in our machine learning challenge. So I'll take the same process and implement here. So I'm going to create a function called as compare models using the cross validation score. Okay, compare models using cross validation. So this is the function that I'm creating. So you have to mention this parenthesis here, and here I'm going to train models individually. So for this, I'll create a for loop. Okay, for model in models. So I'm creating a for loop here. So when we call this function, this for loop runs, and when this for loop runs for the first time, this model will take the value as logistic regression, and it will train with the given data set, and it will print us the cross validation score. The second time the for loop runs, this model takes the value as supported classifier, and so on. So this process kind of happens every time we run this. So for model in model, so I'm iterating this for loop through this list called as models, and each time it will take one model at a time. So this is how it works. So for model in models, I'm going to say CV score. So I'm creating a variable called a CV score, and now I'm going to use the cross val score function. Okay, so I'll copy this. So this cross val score, which I imported from model selection. Cross validation score is nothing but your data will be split into 5 folds, and each time different data fold will be used as your training data and test data. And if you don't know about this, I'll give the link for this cross validation video. You can check that out, and this is like very important. Cross validation is one of the important topics that we have in machine learning. So I'll paste this cross val score function that I imported, and here the parameters that we have to give are estimator, as you can see. So estimator is nothing but the model that you are creating, and x is my features and y is my target. So I'm going to say model. Okay, so model x y and a CV is equal to 5. Okay, so the for loop runs for the first time. So this model will take the value as logistic regression of max iter 1000, and it will go here. So we are using this cross validation score function. So it will basically give you the cross validation score for logistic regression for this data x and y. And x and y is nothing but my art disease data set that I have splitted into features and a target. Okay, target is what you are going to predict, and feature is the values through which you are going to predict this target. Okay, so here I'm going to predict whether a person is having heart disease using the factors like age, sex, and so on. Okay, so we have this cross val score model xy. CV is equal to 5. CV is equal to 5 is nothing but your data will be split into 5 folds. So you will be having like 5 chunks of data, and each time different chunk of data will be used as your test data set. So that is how this cross validation works. And you can also like change this CV into 3 or 5 or some other values as well, depending upon your data set. So this CV score will basically give you 5 accuracy score, and from that 5 accuracy score we have to find the mean accuracy score. Okay, so I'll also print this accuracy score if you want. Okay, so let's print that, but let's print that at a later point of time. So I'm going to say mean accuracy. Mean accuracy is equal to sum of CV score divided by length of CV score. So this is how you can kind of find the average value of this cross validation score. I'll explain you later on how this particular code block works. And this mean accuracy is equal to accuracy into 100. And the next thing I wanted to do is I'll copy this mean accuracy, paste it here, is equal to round mean accuracy by 2 factor. And now let's print this. Print. So just give me a minute. I'll explain you what we are doing here. Cross validation accuracies, um, accuracies for the model is equal to CV score. Okay, so this is the first print statement. And next, let's print our final accuracy. Accuracy score of the model is equal to my mean accuracy percentage. Okay, let's run this one. So what we are basically doing here is, let's say that the for loop is running for the first time, and when I say for model in models, so it will take the logistic regression as I've told you before. Now I'm passing this logistic regression model to this cross val score function, and I'm passing my data, which is my features and target, and I'm saying like I want five folds of data, so I'm mentioning CV is equal to 5. So what happens in this particular step is your data will be split into 5 folds, and your data will be trained using this logistic regression model. So this logistic regression model will be trained with the data that we have passed, and this will happen for 5 times. With each time there will be like different test data because of this 5 folds that we are creating. So the result of this particular CV score line is that you will get like 5 accuracy values. So it will be in the form of a list. So from this 5 accuracy values, we are going to find what is the average of these 5 values. So that will be the final accuracy that we will consider. So for that only we are using this mean accuracy. So mean accuracy is equal to sum of CV score divided by length of CV score. So this is nothing but we take, like, let's say that there are like 5 accuracies. One is like 80 percentage, another one is like 85 percentage, 83 percentage, and so on. And we are adding all those values and dividing it by the total number of values that we have. So in case like there are like 5 values like 80, 85, 83, 84, and 83, so we will add all those values and divide it by 5 because there are like 5 accuracy values. If you increase the cross validation fold, you have to this will change as well, the length of CV score changes as well. And now we are calculating the mean accuracy. So here I'm multiplying the mean accuracy by 100 because the value will be in the range of 0.9. So if a model has 90 percentage accuracy, it will be represented as 0.90. If a model has 85 percentage accuracy, it won't be given as 85, it will be printing as 0.85. So we are multiplying it with 100 in order to convert it to a percentage. So this is just simple percentage conversion. And this step, mean accuracy sum by length, is for calculating the average. This is for converting it to percentage. And I'm going to say mean accuracy is equal to round of mean accuracy comma 2. And the reason we are using this particular step is there will be like several decimal point values. So I'm going to say I want only like two values after the decimal point. So I'm saying like round, I'm going to round this mean accuracy value, and I want only like two decimal places. You can also give like 3, 4 depending on how many values that you want. And finally I'm printing my cross validation score. So I'm going to say cross validation accuracies for the model. So this is my variable that I've created here. So this for loop runs for the first time, it will print cross validation accuracy for the logistic regression is equal to some cross validation values. And again, so this is not in the string, so we have not enclosed this in quotes. So this is actually a variable that we have created. So here it will say accuracy score of the logistic regression model is equal to the mean accuracy, and so on. So let's run this step and see whether this works. Okay, so we have created this function. Now we have to call this function. So I'll copy this and I'll run this one. So this will print me these results. Okay, let's see. So all the splitting of data will happen inside this. Okay, so let me just add one more line to it so that the results are kind of splitted. I'm going to say print. I'll just print some dotted lines here. Okay, so I'll run this again now. So the result will be the same. So we just have this dotted line in between. Okay. So as you can see, this is the result when the for loop runs for the first time. So it will take the value for this model as logistic regression. So that is what is replaced here as well. So cross validation accuracy is for logistic regression, as you can see. So cross validation accuracy for the logistic regression is equal to these 5 values. Okay. So for the first fold of data, we are getting the accuracy as 0.80, which is 80.3 percentage. This is 88.5 percentage, 85 percentage, and so on. As you can see, there is a clear difference between them. So we have like accuracy score in the range of 80. We also have accuracy score as 75 percentage, and so on. So this is why cross validation score is always preferable instead of train test split, because train test split will give you like only one accuracy score, but this is like more reliable as we have like multiple accuracy score and we are taking an average of it. And the average of all these 5 values are this 83.5. So that's what we are doing in this particular step. So when I say CV score is equal to cross val score of model X by CV is equal to 5, This is the result that I get from this particular line. So this is the value of this CV score. So these five values are the value of this CV score, and I am adding all these values using the sum of CV score, dividing it by total number of values, which is equal to 5. And then I'm multiplying this value by 100, and I'm reducing the decimal places. As you can see, there are several decimal places, and I'm reducing the decimal places is equal to 2. So this is how we are converting this value from 0.80 or whatever we have to this particular percentage value, which is 83.15 percentage. So we have two decimal places here because we have two here. So if you replace this 2 with 3, you will get 3 decimal places. So it is completely up to you. It will round the values. So this is the final value for this logistic regression cross validation. And once this for loop runs for the second time, this model will take the value of this SVC, which is my second element of my list called as models. So this is the cross validation score of support vector machine classifier with linear kernel. So these are like some of the basic hyperparameters we choose for these models, and this is the value. And then we have the average of these values is like 82.83 percentage. So this is the cross validation average value for logistic regression. This is for support vector classifier. And finally, as we can see, k nearest neighbor has 64.39, which is very less. And then we have the like accuracy score for random forest classifier as 83.81. So this is how you can compare the accuracy score of different models using this particular simple function. So you don't need to train your model separately in order to do this. You can just create a list with all the models that you want to compare, and you can just build a simple for loop like this, and you will get a result like this. So you can save this code as a template, and you can use this for any other use cases that you're working on. So this kind of saves a lot of time, and this is a pretty good way of doing this model selection. And the thing is, here we are doing this with the default hyperparameter values which we are having. So we are not doing any hyperparameter tuning on all those things. We will do that in the next part of this video. Okay, so we have the list of models, and we are comparing this model. So within this, we have to see which model has the highest accuracy. So it is obvious that logistic regression and logistic regression and random forest classifier has the highest accuracies, and among this, random forest classifier has the highest accuracies, as we can see, which is 83.81 percentage. So this is like very close to logistic regression as well. And k nearest neighbor has the minimum accuracy, which is like 64 percentage. So here I'll create an inference. Okay, let me put this as inference as for this particular art disease dataset. For the art disease dataset, random forest classifier has the highest accuracy value. Okay, so as the highest accuracy value with default hyperparameter. So we are not changing any of the hyperparameter values yet, except for this maximum meter in logistic regression alone. So kernel is linear is like we have to give at least one kernel value, so that's why we are giving it. So with default hyperparameter values. Okay, so let me put this random forest classifier in bold letters. Okay, so this is the inference that we are getting, and the important thing that we have to note here is we are not doing any hyperparameter tuning. So this is what I have mentioned here as comparing the models with default hyperparameter values using cross validation, because we have used this cross val score. And now what we are going to do here is we will take all these four models, and we will check these models for different accuracy score for different hyperparameter values. Okay, so it's like doing hyperparameter tuning as well as model selection together. Okay, so this is the next part of the code, and this is again interesting thing that we have. So let's see how we can do this. So in this case, instead of this cross validation score, we will be using this grid search CV, as we have to do this hyperparameter tuning as well. Okay, so in case this is like enough for you, so in case like you don't have to do any hyperparameter tuning, you just wanted to compare the models with default hyperparameter values alone, in this case you can use this particular code snippet. And after this, what you have to do here is, like, you have this x and y, right? So you have to split this x and y into training data and test data. So we have already discussed about this. So you can also refer my art disease prediction project video in order to understand how we can perform this train test split, train the model, and so on. So after splitting the data into training data and test data, you can, instead of like using logistic regression or SPC, you can use this random forest classifier. So this step is just to understand which model has the highest accuracy, and we cannot like use this any. I mean, we cannot use this further. So this is just for comparing the model. So once you do this, you can train your random forest classifier after splitting the data into training data and test data. So that will be the next thing that you have to do. So I'm not covering that train test split, as we have done that several times before. So once you perform this cross validation, you have to split your data to training data and test data and train the model, do the model evaluation and all those things. And the second part of the code that we are going to do here is comparing the models with different hyperparameter values using grid search CV. So okay, now let's create another list. So it is again the same list, but I'll just copy this and create a new name for this. You can have the same name, but I'm just creating a new one. So let's call this as models list. So models list and logistic regression, I'll just change the maximum meter to 10,000. So if I just use this 1,000, it is giving me some warnings. So that's why I'm using this maximum meter. But the correct way of doing this will be to standardize the data and do all these things. Again, for that we need pipelines. So let's not go in detail about that. Let's change this maximum meter value alone. Okay. And then I'll just remove this kernel is equal to linear. Okay, because that's what we are going to check here. So we'll be checking the support vector classifier for different hyperparameter values, like different kernel values. So we have different kernels like linear, poly, RBF, sigmoid, etc. So we will be comparing all those things as well. Okay, so so we have created a list of models. First is logistic regression with the maximum iteration, support vector classifier, k nearest neighbors, and random forest classifier. So you can also change this random state value if you want, but please include this so that we don't get different results each time we run this code. So now the next thing that we have to do here is, so here we have created a list that contain the name of all the models that we are going to use, the logistic regression classifier, SPC, etc. Now we have to create a dictionary that has all the hyperparameter values. So that is the next important thing. So here we are creating, so creating a dictionary that contains hyperparameter values for the above mentioned models. Okay, so let's name this dictionary as model hyperparameters. Okay, so this model hyperparameters is equal to, as we know, we have to enclose the values of a dictionary in curly brackets. So I'll create this curly brackets. And so we know that a dictionary is a key value pair. So it contains a key and some set of values, right? So the first key that I'm going to create is logistic regression. So logistic regression, I'll just mention this in short form. So logistic regression hyperparameters. Okay, so this is the first key that we have, and here we are creating another dictionary. Okay, so I'm going to say logistic regression hyperparameters is C colon. I'll explain you what we are doing here. So this may seem a bit complex, but this is actually very simple. Let me just complete this and explain you. So here you have to mention what are all the different hyperparameters that we want to consider. So here for logistic regression model, I'm going to change the different hyperparameter for the C value. Okay, so that is what I'm mentioning here. So C can take values like 1, 5, 10 or 20, and so this is my first thing, and there should be a comma here. So this is my first set of values, and the next model that I'm considering is support vector classifier, right? So it will be SVC, support vector classifier hyperparameters. Okay, so SVC hyperparameters. So again we have to create another dictionary within this, and those values are two things. One is kernel, and for kernel I'm going to consider different kernels like linear kernel, polynomial kernel, which is represented as poly, and RBF. So we have discussed about this different types of kernels in our supported classifier video, so we can check that out. So it will be in the seventh module of our course. And then sigmoid kernel. So these are all the four kernels that we have: linear, poly, RBF, and sigmoid. And finally, let's also change the C values. So for C values, I'm going to say 1, 5, 10, and 20. So these are the different C values that I'm considering. So I'll another comma here. And the third model that we have is K nearest neighbor, right? So for K nearest neighbor, I'll mention this as KNN hyperparameters. So we have also discussed about this K nearest neighbors as well. So it kind of checks how many nearest neighbors are there to a particular data point in order to determine its labels. So KNN hyperparameters, and in this case, the hyperparameter that we are going to consider is n neighbors. So n neighbors. Okay, so if you are not sure how I am doing this C kernel and n neighbors is, if you can just search it. So I'll say K nearest neighbor. Scale learn. So let me just search this in Google. So this will take us to the documentation of this k nearest neighbor classifier, as you can see. So these are all the different hyperparameters that we have, and n neighbors is basically the number of neighbors that we consider for determining a particular data point. So if you don't understand this, you have to watch my k nearest neighbor intuition video. So basically, k nearest neighbor works is, let's say that there are like two groups of values. So here we have like data with labels as 1 and 0, right? Similarly, when we are training this model and predicting a new value, this KNN model will check this particular new value that you are predicting is closer to which group of data, whether it is close to 1 or it is closer to 0. So when you say 5, it will like consider the 5 nearest data points to it, and it will say like which data points are maximum. Okay. So if you want a detailed explanation on this, please watch the k nearest neighbor video that I have created. So in this case, the default value is 5, and now I'm going to consider like different values for it. So I'm going to check for different values such as uh, 3 neighbors, 5 neighbors, and 10 neighbors. Okay, and this will be the hyperparameters from a third model. And finally, we have the random forest classifier, and I'll create the key as, let me just include another space here. Okay, so this will be random forest classifier. Okay, so this is my, okay, let me just put this as random forest hyperparameters. Okay, hyperparameters, and here the hyperparameter that we have to consider is my n estimators. N estimator. This n estimators is equal to 10, 20, 30, and 100. Okay, so this n estimator is nothing but the number of decision trees that you need. So we know that we have a machine learning model called as decision tree, where it kind of builds this tree and so on. What is meant by this random forest classifier is that this model contains multiple decision trees. So that is how this random forest classifier has been built, and this n estimator kind of tells it like how many decision trees should be there in this random forest model and so on. So this is how this works, and yeah. Okay, so there should be a comma in this place. Just a second. Okay, so let's try to understand what we are exactly trying to do here. So here I'm creating a dictionary called as model hyperparameters. So what is this dictionary is, it contains the different hyperparameter values for all the models that we have listed here. Okay, so that is the idea of this. And so this is a dictionary, and we are creating another dictionary within this. So we know that a dictionary is a key value pair. So there will be a key and a set of values to it. So for this model hyperparameter, there are four keys. The first key is logistic regression hyperparameters, and the second key is SVC hyperparameters. Third one is k nearest neighbor hyperparameters, and finally random forest hyperparameters. So all these four things represents a particular key, and the second one represents the corresponding values for this key. So this one is the value for this first key, and these two things are the value for second key. Third one is like n neighbors is the value for this one, and so on. The only difference is that instead of having values or list, we are creating a dictionary itself as a value. Okay. So if I build a simple dictionary in this case, just a second. Okay. So let's say that I'm creating a my dictionary. Let me just put this as A. So A is my dictionary that I'm creating. So here I can say name. So like let's say that name of a person is John. Okay. And there is like another key here called as age. And I'm going to say age of this person, John, is let's say 30. And let's say the country he belongs to. Okay. So country he belongs to is let's say US. So this is the dictionary that I'm creating, and I can also like print this A and C. So this is my dictionary. Here we have three keys. One is a name, and then we have this age and country, right? So this is how we create a dictionary. So this keys are similar to what we have created here. So this logistic regression hyperparameters is similar to the key name, and then we have this SVC hyperparameters, right? So in this case we have three keys: name, age, and country. So similarly we have four keys: logistic regression hyperparameters, SVC hyperparameters, and so on. The only difference is that the value for this key name is in the form of a string, right? So this is the key, and the value is John. The value for this key name is John, and it is in the form of a string. And the value that is associated with this age is 30, which is an integer value, and country is again a string. So the only difference is that instead of having string or age as my value, I am having another dictionary within this. Okay, so this is the dictionary that I'm considering it for values. So this is just like saying uh, instead of like John, so what I'm going to say here is like there can be a list with there can be John, and let's say there is like this Sam. So this is the name of different people that we have. So you can also like create this list like this. So I'll run this one. So instead of having string, I have created a list here. So similarly, in this case, instead of having an integer or a string or a list, I have created another dictionary as my value. So this will be the correct way of specifying your hyperparameter values. So this is actually a dictionary, but we are just using it in a different form. So we have the dictionary called as a model hyperparameters, and within that model hyperparameter, we have multiple dictionaries. Okay, so this is the dictionary associated with the first key value, and this is the second dictionary value associated to this SVC hyperparameters, and so on. So I hope you understand this. This is like very important, but this is like very simple thing that we are doing. So in case you wanted to try multiple hyperparameters, so in this case for logistic regression, we have considered like only one hyperparameter, which is like C value, but logistic regression also has other hyperparameter values as well. In that case, how you can do that is like how we have done this for support vector classifier. For support vector classifier, I'm considering like two hyperparameters. First one is kernel, second one is like C. So that's why I have to include this comma here. So I'm just saying like there are like two set of hyperparameters for which I have to check. So this is my first key value pair. So I have separated with this comma. This is my second key value pair. So this is my first set of values. This is my second set of values. This is like third set of values. So all these things should be separated by this comma, and this is like very important. If you remove this, it will be, it will basically show you an error. Okay. So I hope you understand this part. So we are just creating a list of models, and we are creating hyperparameter for the listed models. The only important thing here is we are creating it in the form of a dictionary so that we can use it efficiently. Okay. So model hyperparameters is the dictionary that we have created. So I'll copy this and paste it here. So you can also check the type of this model hyperparameter. So it will tell us that it is in the form of a dictionary. Name is not defined. Okay. Okay. So I have to run this cell first. So it seems like I didn't run this. Okay. So I'll run this one. Okay. So DACT, which stands for dictionary. And I can paste it here and I can say keys. Okay. So let's print this keys of this dictionary. So let's see what is the output we are getting. So when I say model hyperparameter dot keys, so these are all my keys: logistic regression hyperparameters, SVC hyperparameter, KNN hyperparameters, and so on. And I can also check the values of this or items of this. So let me just put this as model hyperparameters dot values. So these are the values. So the value for logistic regression hyperparameters is the C, and the value for SVC hyperparameter is this one, kernel and C, kernel and C. As you can see, all these are given in a dictionary format. So this is how you can analyze the dictionary that you have created. So when I say, uh, you know, let me put this as keys as okay. I'll just remove this one. So I just want this keys alone. I'm going to convert this keys into a list. So let's create a variable for this model keys is equal to list of model hyperparameters dot keys, and I'm going to print this model keys. Okay. Yeah, so I have created a list which contain all these keys. So we need this in order to access the data that we have. Okay, so how you can do this is like if you copy this name model hyperparameters, and if you say the name of a particular key. So this is my first key. I'll copy this. If I paste it here, so if I paste this within the square bracket, I will get the corresponding value for this particular key. As you can see, if I just replace this with this SPC hyperparameters, I will get the corresponding value for subprotector machine classifier. So this is how we are going to access the individual hyperparameters for the models that we have created in this list. Okay, so that's why I've created this list called as model keys. And instead of using this SVC or hyperparameters and something like that, we are going to use the index of this particular list. Okay, so I'll say, mm, so this is the list we have created. So let me just move this cell above. So this is my keys, and this is the list that I've created. And we know that we can print the first value of the key using the index, right? So when I say model keys of 0, and model keys is the list that I've created, when I say 0, this first element will be printed. The first element is logistic regression hyperparameters, right? When I say 1, the value with index 1 is SVC hyperparameters, and 2 is for k nearest neighbor hyperparameters, and so on. So this is how we can print this, and this is what I'm going to use. So I'm going to all these keys, instead of like mentioning their name, I'm going to call them from this list called as model keys. So the important things that we have to do here are creating this list that contain the name of all the models, creating this dictionary, and converting the keys into a list. So these three are like very important steps that we have to consider. So first is like creating the list, second is creating the dictionary, and converting the keys in the form of a list. So when I say model hyperparameters, model hyperparameters, and within this, instead of instead of mentioning this SVC hyperparameters or logistic regression hyperparameters, I can say model keys of 0. So when I say model keys of 0, so the value that I will get is, so this is how I'm going to access my hyperparameters. Okay, so if I say keys of 1, I will get support vector machine classifier hyperparameter. So what I'm basically doing here is, instead of saying model hyperparameters of SVC hyperparameters, I'm going to say model hyperparameter model keys is equal to 1. So we are just doing this in a in a different way. The reason is we will be creating another for loop. So we'll be creating a function, and we'll be creating another for loop like we have done for this one. And in that case, instead of using the keys as such, it is always better to kind of load it to a dictionary and call the values using this index. So you will understand why we are doing this, but these are all the steps that we have to do before creating that particular function. First is creating the list, and then creating the dictionary, and converting the keys in the form of a list. Okay, so as we have done here, so I'm taking this list, and I'm converting all these values into a list using this list keyword. Okay, and now let's try to create this function that kind of do this model selection, but with different hyperparameters. Previously, we have trained our model with only the default values, right? Now I'm going to consider different hyperparameter values. So, and yeah, so here I'll just make a text here as applying grid search CV. So grid search CV is the hyperparameter tuning function that we have, and this is how we are going to select our models as well. So I'll create a function as DEF. So DEF stands for define, which is used for creating a particular function. And I'll name this function as model selection. Okay, so model selection, or let me put this as like this, model selection. So let me just change the case of M and N, sorry, M and S. And the parameters that I give to this particular functions are the list of the model that I have created, and the hyperparameter dictionary that I have created. Okay, so here I'm going to say uh, list of models, or let me just put this as So let's not use the same name that we have created here. So let's put this as models. So first models, and the next thing is hyperparameter. So let me just put this as hyperparameter, hyperparameter dictionary. Okay, so I just don't want to use the same variable name that we have here. So model hyperparameters model list. So let me just put this as list of models. Okay, so list of models and hyperparameters dictionary. Okay, so I don't want to use the same thing because like it will be directly passed to it. So I'm creating a function that I'm mentioning like that we have to give two parameters to this. So the first parameter is the list of models, second parameter is the hyperparameters dictionary, the two attributes that we have. And the reason I'm creating this function is if you want you can add another model to it. So you can add another classification model to it, and you can add the corresponding hyperparameters to that particular model as well. So that is this reason I'm creating this. So the name of this function is model selection, and here I'm creating an empty list. So result is equal to, I'm creating an empty list. So this is where, so in this list only we will store all the best hyper parameters. So we will like check which parameters has the best value. So we will be storing all those things in this empty list, which is result is equal to this square bracket. So this is how we can create an empty list. Then going to say I is equal to 0. So we need this I. So this I is just for this index. So we have seen that we will call the hyperparameter using this index, right? So for that we are creating this I, and I'm initiating this I as 0, and this is where I'm going to create my for loop. For model in this list of models, okay? For models in list of models, key is equal to model keys of I. So this model keys is nothing but the list that we have created here. Yeah, so this is the list that we have created, and I is the index. So the for loop, when the for loop runs for this first time, the value of I is 0. So model keys of 0 is nothing but, so when I say model keys of 0, or when I say model keys of 0 here, the value that it will print is logistic regression hyperparameters, right? So that is what I will get here. So when I say key is equal to model keys of 0, the value of key will be logistic regression hyperparameters. And now the parameters. So we have to check what is the parameter. So I'll create a variable as params. So this is where we are going to pass the parameters of this logistic regression model. So I will say model hyperparameter, model of keys, that particular index, right? So I can say this as um, the hyperparameters dictionary. So if you don't understand what we are doing here, is like, please hang on. So once I complete this, I'll also explain you clearly on all the steps that we are doing here. So it is, I'm going to say key, okay, and then I am going to increment this equal to 1, and I'll also print the name of the model, and I'll print the hyperparameters that we are using this params. Okay, so what we are basically doing here is like we are just specifying the model that we are going to use using this for loop, and I'm just creating this index so that we can call that specific model's hyperparameters. So I'll also explain this again, but this is for combining that model and the hyperparameter of that particular model. The reason is that I cannot use this set of hyperparameters, right? I cannot use this C and kernel while I am training the model with this logistic regression, right? So whenever I'm training with this logistic regression, I should use this set of parameters, and while I'm training it with this SPC, I have to use this SPC hyperparameter. So that's the reason, and yeah. Mm. So that is why we are creating something like this. And once we have done this, we can build our grid search CV function. So we'll create a variable as classifier. So classifier is equal to, we have to use the grid search CV function, grid search CV, and we have to give the model. So the first attribute that we have to give is like the model which using which we are going to train our data. Then we have to give the params, the parameter that we are considering, and CV. So what is the cross validation, number of folds for your this cross validation, and so on. So this is like creating the instance of this grid search CV using this classifier variable, and now we have to fit the data to this model, fitting the data to classifier, and I'm going to say classifier dot fit. classifier.fit x comma y. So this classifier is nothing but the grid search CV. So when this for loop runs for the first time, so grid search CV will be applied for logistic regression, and the logistic regression will be trained with the training data and test data. The result is that we will get the accuracy score for all the different hyperparameters that we have used. So we will get the accuracy score when we use hyperparameter 1 and hyperparameter 5, 10, 20, and so on. So this is what it kind of happens. And finally I'm going to store this best result in the list called as result. Okay, so this is why we have created this empty list. I'm going to say result dot append. So append is the function that we use in order to add new values to our list, and I'm going to do this again in the form of a dictionary. So I'm going to say model used, model used. So we have to mention model. So if you haven't watched my grid search CV video, the hyperparameter tuning with Python video, please watch that video first, and then only you can kind of understand how this grid search CV works and so on. So that is like very important. Otherwise, this may not make sense to you. And the next thing I wanted to add is the highest score for a particular parameter. So highest score is equal to, I can say, classifier dot best score underscore. So you have to mention this underscore after score. And the third thing that I'm going to consider is best hyperparameters. Okay, so best hyperparameters is classifier dot best params. So best, okay, so best params, this will be stored. And finally, let's create a simple data frame using this dictionary. So result data frame. I'm creating a data frame here, which is equal to pd dot data frame, and result columns is equal to, first column that we will put is the model used. So these are the column names for my model. And the second thing that we have to consider is the highest score. And finally, the best hyperparameters. Okay. So we are just finding the hyperparameters for which we are getting the highest result, and then we are storing it in a dictionary. And finally, we can return this return this data frame. So return result data frame. Okay. So this is the function that we are creating. Okay. So I think everything is correct in this case. Yes to score. Okay. So we have to put a comma here. These are different set of values. Let's run this. Now I'll call this model selection, and now I'll pass my models that I'm comparing, which is my models list, and then this model hyperparameters. Okay, because these are the two parameters that we have to pass. One is we have to pass a list that contains the name of the models that we are using, and then we have to pass a dictionary that contains the hyperparameter values. The first is the models list, and the second one is model hyperparameters. Okay, we run this one. The models list is not defined. Okay, I think I didn't run this cell maybe. Yeah, so I didn't run this cell, so that is the reason. I'll just run all these things again. Accepted. Okay, so there is some issue that's happening in this code. Let me just check this one. Okay, so this result thing should come out of the for loop. As you can see, there is a for loop that we have here. So come out of this. Okay, let me run this again. So training the support classifier will take a bit more time because we are considering like two set of hyperparameters in this case. So what happens is like in the first set of cases, logistic regression will be trained for these different hyperparameters. C is equal to 1, C is equal to 5, 10, 20, and so on. And after that, for support classifier, we will train with kernel is equal to linear and C is equal to 1. Then kernel is equal to linear and C is equal to 5. Then linear 10, linear 20. And then after that, kernel poly and C value of 1, 5, 10, 20. All this will be trained individually and so on. So what happens here is, so we have already created a list which contain the four models: logistic regression, SBC, k nearest neighbor, random forest classifier, right? And we have created the set of hyperparameter for the corresponding models as well. And then we have created this list called as model keys. So these three things are important, as I've told you before. Now we have created this function called as model selection, and the two attributes or parameters that this particular function takes are list of models and hyperparameters dictionary. So you have to pass these two values to it. And within this function, what I'm doing here is I'm first creating an empty list called as result, and I'm creating this I is equal to 0. And after that, I'm performing this for model in list of models. So when the for loop runs for the first time, it will check like what is the first value in this list of models. So the first value in the list of models is this logistic regression of maximum meter 10,000, right? So this model value will be logistic regression maximum meter 10,000, and key is equal to model keys of I. So when I say model keys of I, the first time the for loop runs, the I value is 0 because I have initiated the value here, right? So model keys of 0 is nothing but it's same of saying model keys of 0, which is equal to logistic regression hyperparameters. And so here the value of this key will be this logistic regression hyperparameters. After that, params. So here we are passing the parameters of this logistic regression. So I'm calling that by parameters dictionary, which we are passing key. So it is similar to saying model hyperparameters. Within this, we are saying like logistic regression hyperparameters. Okay, so let me just copy this and paste it here. So it is like similar, like same way of saying this. So instead of saying model hyperparameters of logistic regression hyperparameters, I'm going to say params hyperparameter dictionary key. So it is like both are the same things. So as we are doing this in for loop, this is more efficient way of doing this. And after that, I'm incrementing this I value. So the reason is that the second time the for loop runs, it will take the model as SVC and it will automatically choose this SVC hyperparameters. If you don't increment this I plus, so I is equal to I plus 1. So in that case, what happens is that the model that is trained will be SVC and the hyperparameter will be considered as these hyperparameters. So we don't want that, right? So we want logistic regression and the corresponding logistic regression hyperparameter, SVC and this hyperparameters. So that's why we are incrementing this I. So first we have initiated this and we are incrementing this. And every time we are just printing the models and the parameters that we are using. So we are printing it, and after that we are training a grid search CV, and we are printing the best results and so on. So this is the first set of value for which the grid search CV is trained. First with, it will train the logistic regression model with C value 1, 5, 10, and 2 on. So this is what we are printing here. Print model and print params is what is happening here. So this is when the for loop runs the first time, and after that we are training us. So the for loop, so totally the for loop runs for 4 times. The second time it runs, it will train our support vector classifier, and it will check for these different hyperparameters: linear, poly, RBF, and sigmoid, these values. So third time it runs, it will train with this k nearest neighbors classifier and so on. I'll also put another dotted lines here so that you kind of understand the count of this for loop. Let me run this again. Okay, so this will take some time. Okay, so this is when the for loop runs for the first time. This is when it runs for the second time. So here we are passing this grid search CV. So again, if you want to understand this performance or how this grid search CV works, please watch my videos on hyperparameter tuning, like a theoretical video as well as the hands-on video that we did. I'll also give the link of that video in this video description. So you just have to watch all the videos in my module 8. There are like 5 or 6 videos. So please watch all those videos. This is like 8.6. So watch all the 5 previous videos, so then only you can understand this clearly. So grid search CV, what it basically does is, so it will take a model like logistic regression, and it will try to find the accuracy score when we are using like this different hyperparameters. So when you are using C is equal to 1, you will have a accuracy score like, let's say, 80. And let's say when we are using the hyperparameter value C is equal to 5, we will get a different accuracy score and so on. So it will calculate all those accuracy scores. So each time the for loop runs, we will check this for each model that we are considering. After that, once we are like, completing this training and so on, we are finding the best result. So I'm saying like model used is equal to model. So this model is nothing but the values that I'm taking from the list of models. So this one. So this logistic regression. So first time the value for this model is model, and then we have this classified or best score. So what happens is like it will tell you what is the highest accuracy that particular model has reached. So what is the for all these four considerations of this hyperparameter for 1, 5, 10, and 20. What is the highest accuracy that you are getting, and what is the best parameter? So best parameter means for which hyperparameter you are getting highest accuracy, whether you are getting the highest accuracy when using 5 or you are getting highest accuracy when using 20 and so on. And similarly we get for all these things. So for which set of for which combination of this kernel and C you are getting highest value, and what is the highest accuracy and so on, and we are just loading it in a pandas data frame, right? And we are creating this column names as model used, highest score, and best parameter, and this is our final result. Okay, so as we can see, so we have used like four models. So this is the first column, name of the model used, what is the highest accuracy for that particular model, and what is the best hyperparameters for that model. So how we have to infer this is, when using logistic regression, the highest accuracy score that we are getting is 0.8315, which is equal to 83.15 percentage. So this is in this zero, like in the range of 0 to 1. So this is actually the percentage value. You can just calculate this one. And you are getting this highest accuracy of 83 percentage when you are giving the C value as 5. And if we come to the next one, when using the supported classifier, the highest accuracy that you are getting is 82.8, almost 83 percentage, and you are getting this highest value while you are giving the hyperparameter values as C is equal to 1 and kernel is equal to linear. So while using this hyperparameter, you are getting the highest value. So this is for k nearest neighbor. So instead, like if you use different k nearest neighbor values, like as we have mentioned here, 3, 5, you will get less values. Sorry, I think like the value is 5, right? So okay, so n neighbors value is 5. So instead of using a n value of 5, if you use 3 and 10, you will get less values. Similarly, if you use poly, RBF, or sigmoid, and if you use like 5, 10, and 20, you will get lesser accuracy score. So that is what we are understanding from here. And for random forest classifier, 83.8 is the highest accuracy that we are getting, and we are getting that when we are using the n estimator is equal to 100. So if you use like 50, 40, or 30, we are not getting highest accuracy. So this is how you can compare different, not only like models with default hyperparameters, but with different set of hyperparameter values. So these are all the different hyperparameters that we have considered. And once we have come to this conclusion, so now we will split our data into our training data and test data, and instead of training it with logistic regression or SPC or k nearest neighbor, we will train our random forest classifier model. And the important thing is we will choose this n estimator is equal to 100. So this is how you can kind of do model selection as well as hyperparameter tuning for multiple models. So in this case, I have just considered like few hyperparameters so that this code kind of looks simple. So apart from the C, we also have different hyperparameters for logistic regression and for k nearest neighbors, as well as for random forest like random forest also. So if you see this, k nearest neighbor, we also have this different set of values that we can consider. So along with this n neighbors, so you can just put a comma here and you can just create a list with all these values as well. So this is just similar to this kernel and C. So here we have considered two hyperparameters. In other cases, we have just considered only one hyperparameter. So you can also use these hyperparameters as well, and you can train that for that combination as well. So this is how you kind of you can do this model selection and hyperparameter tuning. So once you've done that, once you have find which is the best model and best hyperparameter, do a train test bed and train with that particular hyperparameter. So what will be the next step here is I will split my x and y. So I have this x and y, right? So I have this x and y. So I will split this x and y to training data and test data. So once I split this, I will train my training data with my random forest classifier, and I will pass my n estimated value as 100. So this is the best result I get. So this is how we can do this model selection in Python. So let me just put text here as my inference. Random forest classifier seem to have the highest accuracy. Or let me put this as random forest classifier with n estimators is equal to 100 as the highest accuracy. Okay. Okay, so highest accuracy, and it's not like this is the only result that you get. So if you consider different hyperparameters, there can be different result also. You may also get like k-nearest neighbor can also be a good model, but it is like highly unlikely. But if you consider different hyperparameter, you may get a different result. In this case, I just considered only like one parameter in each case, except for SPC where we have considered two hyperparameters. So you can try that well, where you can consider different hyperparameters as well. And I hope that you have understood all the contents covered in this video. And that's it from my side, and I'll see you in the next upload. Thanks for watching.